Hello and good afternoon, CTS265 Section 840 students for the Fall 2016 semester at Anne Arundel Community College. This is the CCNP route course, and this afternoon's video tutorial is going to be a tutorial and solution set for Lab 2-2, which we are going to be focusing again here on EIGRP stub routing, and we're going to have a little, very minimal amount of summarization that we need to take care of as well. As you can see here from the drawing, we're going to be in EIGRP Autonomous System 100 with router 1 and 2. Router 3 is going to be an external router, and we're going to be looking at a default and a static route here between router 2 and router 3. So let's go ahead and dive in. Again, we're going to be starting on step 2, configuring EIGRP, and I've actually had to basically had to wipe the routers clean here. So 6, 9, and 8, I actually just went ahead and changed the names as well to kind of make it a little easier here. So on router 1, we're going to go from user exec to privilege exec into global config. We're going to say router EIGRP 100, and we're going to put network 10.10 or 10.0.0.0. Again, we're using the classful network boundary by not putting a wildcard mask in. And on router 2, let's go ahead and step over to router 2 here. Go from user exec to privilege exec into global config, router EIGRP 100, and we're going to do network 10.0.0.0. And then we're also going to put a network statement in for our 192.168, and let's make sure we get this right, 192.168.0.0. And this is going to be a /16. So we're taking that typically a class C, which is a /24 address, but we're going to subnet it as if it is a class B subnet applied to it to make it a /16. All right, so now we're going to summarize R2's loopback addresses. And so if we come back to the preview here, in order to do this summarization, it would be very straightforward. Actually, let's bring that back. Where did that drawing go? There we go. All right, so we've got these. And that's interesting. So they're set up as /30s, but the interesting octet here is that third octet, 1, 2, 3, and 4. So if we work it out over here, 1 in binary is 0001, and then 0010 is equivalent to 2, and then 3 would be 11, and 4 is going to be 0100. So our subnet mask, which is going to be the last bit position where everything matches, it was this bit position here. So we've got the first 16 bits of the same, 17, 18, 19, 20, and the 21st bit is the last bit that matches. So we know we're going to have a /21. Then we take a look at the values. Well, there are no bit position values in the on position here in that third octet. So we're going to be looking at a 192.168.0.0/21, and that is going to be the summary that we would use. And so when we put the command in, we need to put the dotted decimal format of the CIDR notation. So we would have 255.255 dot, and now we've got to figure out, we've got how many bits, 1, 2, 3, 4, 5, so it would be 128 plus 64 is 192 plus 32 is 224 plus 16 is 240 plus 8 is 248.0. All right, so 192.168.0.0, and then 255.248.0. So let's go ahead and clear our palette there. And again, we're going to be doing this here on router 2, and we're running EIGRP between router 2 and router 1. So the summarization is not going to be done on this interface here. We're going to be doing it on the serial 00 interface right there. So let's go ahead and go into interface serial 000, where we would say IP summary address EIGRP, what AS number, 100. And then what is our summary? So again, 192.168.0.0, 255.248.0. And before we do that, let's just quickly say do show IP route EIGRP and see what the routing table looks like prior to us doing the summarization. And so here's all the prefixes we're learning via EIGRP. And now let's apply the summary. So what we should see happen is a graceful resync. Again, it's a graceful restart, so the adjacency does not get torn down. If I say do show IP EIGRP neighbors, we'll see that the adjacency is still in good standing, has been for 3 minutes and 45 seconds, so it didn't tear that down. And if we say do show IP route EIGRP, you can see that we have shrunk the size of the routing table. But again, I need to stress that while this is a nice byproduct of summarization, it was not the primary goal or one of the more important goals of summarization. Remember that when we're talking about doing summarization, it's all around our ability to limit the size and the scope of the EIGRP query domain. And so now that we have provided that summary, and so I take a step back, so the query domain, and then also the summary will continue to be advertised as long as one of the component routes in the summary have been or are up, right? So as long as one of the component routes that make up that summary right there, as long as one of those is in an up state, the summary will continue to be advertised. All right, so now let's go ahead. We want to create our static routes now. So on router 2 and router 3, let's go ahead and do that. On router 2, we're going to back out of the interface config mode, and we're simply going to say IP route, and it's a static route to get to the 10.1.5.0 network, and that's over on router 3. And it's a /24. Our next hop would be 10.4.4.2. And again, if we pull up our drawing, you can see here's the 10.1.5.0 network, and our next hop is that 10.4.4.2. So the next hop is the serial 010 interface on router 3. All right, so let's add that in, and there's our static route to the 10.1.5. Now, what if we try to ping? Let's see what happens. So 10.1.5.1, and I'm not sure that's actually, let me take a quick look here, or actually that is router 2 on router 3. Let's get into privilege exec, show IP interface brief. 10.1.5.1, so that is the network on router 3. And let me see something here. Show IP route. All right, so I do have a route back locally connected to the 10.4 network, which is why those pings went through. But now we want to put a default route on router 3, default static route. So IP route, we'll do our quad zeros. And then our next hop would be 10.4.4.1. Is that right? Yep, 10.4.4.1. And so now we have our default route set up on router 3. We've got our static route set up on router 2. From router 3, can I ping 10.3.3.1? And let's say do ping. All right, and we've got connectivity. How about over to router 1? Can I ping the 10.1.1.1? So let's see if we can ping 10.1.1.1. And we can. We've got reachability all the way over to router 1. So on router 2, if I say do show IP EIGRP neighbors, do show IP EIGRP neighbors, what we're going to see is we have that single neighbor relationship. Here are the column headings, H for handle. Again, that's the first adjacency that we have, and it's indicated by that number 0. You can see the IP address, the 10.221. That is the IP of the neighbor. And then we've got the serial 000 interface. That's the interface on which we've learned about the neighbor. And then again, we've got our hold time, smooth round trip time, RTO, no queue count, and 7 reliable packets have been received. And that was the last sequence number that we received. So does R1 have a route to R3's LAN? And the answer is, let's go take a look on R1. Does it have a route? Do show IP route to the 10.1.5. It does not. So there is no route here on router 1. But what if I were to say do ping 10.1.5, 5.1? What happens? Nothing, right? Because we don't have a route to the LAN segment on router 3. What we do have a route to, and so this might be, let me take a step back, because you're probably asking yourself right now, wait a second, I just saw you ping router 1 from router 3. But remember, when I initiate the ping from router 3, what is the source IP going to be? Is it going to be the LAN segment, or is it going to be the IP address of the outgoing interface serial 010, which is the 1044.2? Exactly. By default, when I initiate this ping, that is the network that is the default. And if you look over here, remember, we fired EIGRP up on the 10.0.0.0 boundary, which includes that network segment, which is router 2's serial 010 interface. So for me to ping from 3 to 1 works fine, and from 1 to that IP address is going to work as well. But from 1 to that IP address, we have a problem, because router 1 does not know how to get to the 10.151, and the gateway of last resort, if I were to move that out of the way, is not set. So there is no default candidate here. There's no default route on router 1. So that connectivity is not going to be achievable. If I were to go back to router 3, and this is an important point, and say do ping, let's call that back up, and source it from loopback 0, which is simulating that LAN network, take a look at what happens. Because look, packet sent with the source address 10.151. It gets over to router 1, but it has no clue how to get back to router 3's LAN segment. And so that's just proving the point that that is not going to work. All right, so step 3, and there's a couple of ways I could fix that, right? I could put another static route onto router 1, saying to get to the 10.150, go to router 2, and then put a static on router 2 that says to get to the 10.151, but we're not going to be doing that. So we're on step 3. So we're going to be looking at EIGRP stub routing, right? And the different options that we have: connected, static, summary, redistributed, receive only. And so remember that by default, if I do nothing other than say EIGRP stub, right, that simply makes me a stub router. The default options are connected and summary. So let's go ahead and jump on to router 2 here. And so again, let's talk about real briefly why it is we're going to set router 2 up as our stub router. And you can see we've got the headquarters network over here behind router 1. And so what we're saying is that router 2 is going to be our stub, because we're going to tell router 1, hey, if you lose a network, there's no need for you to send me a query. I'm proclaiming myself to be a stub router, therefore I'm letting you know that no matter what network it is you lose back here, don't ask me how to get there, because I have no idea. I am not going to know. I'm going to limit the query boundary right to there. Now, in the setup that we have here, it's a little contrived, right? But you'll notice there are no routers behind router 2 anyway. Typically, when you would do this is if you had additional routers, right? Maybe going across really slow WAN links, maybe going across, a satellite link of some kind over to another satellite dish over here, right? And then another router out here somewhere, where we know that there's no other path over here to get to a network that router 1 might lose and might need an alternate path. So if we know that that's the case architecturally and topographically, let's make router 2 a stub and say, hey, don't bother sending me queries for anything that you lose, because I am not going to know how to get there anyway. All right, so let's go ahead and set router 2 up as a stub. We're going to go into router EIGRP 100, and we're simply just going to say EIGRP stub. And I'll do the question mark here. You can see there's connected. That's one of the two defaults. There's summary, which is the other. We've got static, redistributed, receive only, which is the stub basically saying, I am not going to be advertising any EIGRP information that I've learned or that I have. I'm only going to be receiving information. And then we have the leak map, which will allow prefixes. If we wanted to let prefixes be leaked out, we could. All right. So just EIGRP stub. Now, this is definitely something you don't want to do in the middle of your production day. As you can see, it tore the adjacency down, and we can confirm that. Do show IP EIGRP neighbors. And how long has the adjacency been up? 8 seconds. So it did get torn down, and then it did get stood back up. If we come over to router 1 and say do show IP EIGRP neighbor detail, right, this is where you're able to see that it's a stub peer advertising only connected and summary routes. So if it's not directly connected and it's not a summary, it's not going to be advertised over to router 1. All right, so let's make sure that we've got everything. It says, what EIGRP stub options are implemented by default? We already know it's connected and summary. And let's confirm that. I can say do show IP route EIGRP. And what am I seeing? I'm seeing the connected 10330, the 10440. Remember, that's the segment between 2 and 3. And I'm still seeing my summary. Again, connected and summary. That is the routing information that the stub router, router 2, by default will advertise to router 1. Now, the key thing to remember here is if I were to say on router 2, let's say debug EIGRP packets sorry about that. In fact, let's get out of here to debug EIGRP, IP EIGRP packets, or just EIGRP, sorry about that, EIGRP, had to write the first time, EIGRP packets, and we will say terse. Right, so we're going to be debugging quite a bit of stuff, and what we're going to be looking for is we're going to be looking to see when router 1 loses an EIGRP, or when loses a route to a prefix, what does it do, right? So is it going to send a query or not? And so if I were to take down, I believe, what are we doing here? Let's say do show IP interface brief. So if I were to go into interface loopback 0 and shut that down, the 10111, what would happen? Right? So let's go ahead and quickly all. So we'll kill the debugging there. So the 10111, right? We went ahead and we removed that, and you can see if we roll back up. So an update message came in on serial 00 from neighbor 10221. And that was when we removed it. But again, so we're receiving an update. It's not a query. We acknowledge the update because we have to. It's being sent reliably. And then we send our acknowledgement, sequence number 11. Now you'll notice we are in-queuing a query on serial 000. But again, this is not us receiving the query. This is router 2 sending the query. Because what has happened is the 10111 or the 10110 network has gone away. An update message comes through the serial 000 interface indicating that that's it. That router 1 doesn't have reachability to that network. And so then router 2 is going to send the query. You can see it right here, sending the query to neighbor 1. And it's being sent reliably, sequence 11 over 11, and it's being sent reliably because router 2, who now realizes, hey, if router 1 is telling me he doesn't know how to get there, I need to check to see how I'm supposed to get there. So he is going to send a query to router 2, or I'm sorry, to router 2 sending the query to router 1, basically asking, hey, yeah, I'm removing it and I don't have a way to get there either. right? So it doesn't receive the query. It limits the query domain in that there will be no propagation of a query from router 1 to router 2 and then out to all or any routers that are running EIGRP behind router 2. But this query is nothing more than router 2 also removing the 10110 network from its EIGRP topology table. And that's what that query is, right? It's not so much a query saying, hey, do you know how to get there? It's more of a query saying, hey, I don't know how to get there, and I'm removing it from my routing table. And then here you see we get an acknowledgement back from router 1. Basically saying, yeah, I acknowledge I've received that you don't know how to get to 10.1.1.1, right? And that you have removed 10.1.1.1. Okay. And we've got the debugging has been turned off. So let's go ahead and bring the network back up for the gig 00 interface. And so now what we're going to do is let's go ahead and let's manipulate some of these settings here on router 2 in terms of the stub. So router EIGRP 100, EIGRP stub, and let's only do static. And actually, we're going to redistribute static first, it looks like. So let's do that. Redistribute the static, and that, remember, this is going to redistribute the 10.150 network, which is the LAN segment behind router 3. It's going to redistribute that. And we are now going to make that redistribution happen via EIGRP. But take a look at what happens, right? We reset the adjacency. If I come over to router 1 and take a look and say, do show IP route EIGRP, am I going to see the connected and summaries, or am I only going to see that redistributed static route to 10.150? And again, that's all we're seeing is the 10.150, and that's the redistribute static. Okay, so the question is, why does R1 only have R2's static route to R3's LAN? Well, it's because when we say do show IP EIGRP neighbor detail, what is being advertised? Stub peer advertising only static routes. But again, it's still suppressing the queries. So in order to fix this, and again, this is where you can combine, you can mix and match the options that you're using, and that's exactly what we're going to do. We're going to go ahead and say EIGRP stub connected, whoops, we're going to say EIGRP stub, and we can put in here connected, summary, and static. Now the only one that we can't mix and match with others, and you'll notice it's not here because it can't be mixed and matched with anything. If I were to come back here after connected and say question mark, which one don't you see that we were seeing when I did the question mark after the stub? Connected, summary, static. There is no option. Once you put in connected, summary, static, leak map, redistributed, receive only is no longer an option. Receive only is the only option that cannot be mixed and matched with the other options. And so keep that in mind as you go forward, and we're just going to go ahead and do connected, summary, and static. Now again, this is going to tear the adjacency down. Not something you want to do in the middle of a production day in the core of your network. And if I were to say do show IP EIGRP neighbor detail, now we're looking at connected, summary, and static. So if I were to look at the routing table and basically say do show IP route EIGRP, we now have back our connected, which are the 10.3.3 and the 10.4.4, and our summary, which is that 192.168. And so this is how you can perform layer 3 traffic engineering using a stub. So now on router 1, right, do I have a route to that 10.1.5 network? Yeah, now I do have a route to get there. So if I were to say do ping 10.1.5.1, now I've got reachability. And likewise, on router 3, if I were to say ping 10.1.1.1 and source it from the loopback 0 address, we've got reachability. Excuse me, I had to sneeze there. All right, so now we're going to configure the receive only option by itself. And the question that we're going to try to answer here is, what EIGRP routes do you expect router 1 to have in its routing table? Because when we set router 2 to be receive only, EIGRP stub receive only, and look, you can't combine receive only with anything else. No leak map, no connected summary, nothing. Can't combine it with anything else. It's got to be used by itself. So EIGRP stub receive only, and I hit enter, and yes, this is definitely going to reset the adjacency. Let's step back over to router 1 and let's say do show IP route EIGRP. And what EIGRP information have we received? None, right? Because router 2 has said, hey, router 1, I am a receive only EIGRP stub. Therefore, I will not be advertising any EIGRP information to you. None. So let's see what that looks like. Do show IP EIGRP neighbor detail. And it's definitely suppressing queries still, right? So all of these options have one thing in common with summarization. And it's really, again, one of the major benefits of summarization is limiting the size and scope of the query domain. Okay, so we get the neighbor detail output, and we see receive only peer, advertising no routes. It's suppressing everything. And so let's take a look at something that's very interesting here. We're going to say debug EIGRP packets, and there's a verbose option, I thought. We'll say all, and I think it's verbose. There used to be a verbose. Or detail, sorry. Detail. All detail. So we're going to debug all EIGRP packets. And this is what I want you to see. So remember we talked about the TLV, the type length vector, or type length values that EIGRP is communicating. And it's communicating those, as you can see here, receiving peer info, right? Sending hellos, and it's doing it in the hello packets. Okay, so EIGRP sending hello, and the received hello went right by, but there it is. So we're receiving hellos and we're sending hellos. So if I say you all and I kill the debugging, look at what we're receiving from router 2. So type 1 length is 12, and there's the vector value. Type 4 vector value, and the type 6 vector value, right? So let's see what happens if we're debugging this and I come over here and I say EIGRP stub summary static. Now that's going to tear the adjacency down, but watch what happens when the adjacency comes back up. The values that we were receiving before, and actually that was not what I wanted. We wanted that. The values we were receiving before are now going to change. Now this type 5 value, we're going to see that momentarily. This is going to disappear. That is for multi-topology routing, which is something that really didn't take off. And then you can see it's gone, right? So when we're receiving, and let me go ahead and let it run one more time here, and we'll say you all to kill debugging. So the received flags, when we take a look at the received flag values, again, we've got the type 1, right, with a length of 12, and then here is the value. And then the same thing here, type 4, and then we've got the type 6. And this type 6 we are very interested in, because this is the value that is being communicated from router 2 to router 1 to tell it, not only am I a stub, but what kind of a stub am I? And you can see here that hexadecimal value E. Well, if we scroll back up prior to making that change, what was the value when we were receive only? It was 8. And so this is exactly how EIGRP communicates the stub configuration from one router to another. It's in the hello packets, and it's using those TLV values. I'm scrolling back down here. It's using those TLV values to indicate with the 000 echo hexadecimal value to say, hey, I am a stub that is only set up for summary and static. When it was receive only, it was 8. And let's confirm that. So let's prove that that's the case. Let's kick off the debug again. Kick off the debug again. And we're going to come back and say EIGRP stub receive only. And we step over here and then you saw the 8 go by. If you're watching real quickly there, you could see the 8 go by. And there it is right there. And again, that F5 value, that's the multi-topology routing, that will go away eventually. And we won't be seeing that. But there it is. Type 6, the length is 6 bytes. And there is the value indicating I am a stub. And so I love the debugs because you can really see the information, what's going on behind the scenes with the protocol. And it tells the story of, hey, the stub feature has changed. We've got a new value here, and that's what the value is going to be set to. All right, well, this is going to wrap up the Cisco Networking Academy Lab Activity 2-2, where we took a look very briefly at summarization, very simple summary, and we looked at the stub feature. Again, keeping in mind that the value of stub routing in EIGRP and the value of summarization in EIGRP is not about shrinking the size of the routing table when you type show IP route. It's not about shrinking the output, right? That is definitely a byproduct of summarization and stub routing. The primary goal of stub routing and summarization is to limit the scope of the EIGRP query domain. And we saw that we don't get queries from router 1 when it loses a network, that it's not going to be sending a query that then needs to be sent all over the place, that it simply knows, hey, router 2 is a stub. There's no sense in me sending a query over to router 2 because he has already told me I am not going to know how to get there, so don't even bother asking me. All right. Enjoy the rest of your weekend, and I will see you all tomorrow night.